We're moving on today to a new type of measuring angles, and they're called radian measure. And as you can see, the word radian is a derivative of the word radius, or the word radius is a derivative of the word radian, whichever way you want to look at it. So let's just go back for a second, and let's remember this is a unit circle. And a unit circle means the radius is 1. So if I were to do the circumference, remember circumference is pi times diameter. So the circumference is pi times, well, the diameter would be double the radius, which is 2. So the circumference of a unit circle is 2 pi. So let's hold on to that thought for a second, and let's go and figure out what a radian actually is. A radian means we took this radius of the circle and we laid it out on the circumference of the circle. There's me laying out radii on the circumference. But I have a better visual for that. This is what a radian is. Remember, a radian is the angle made by taking the radius and wrapping it along the edge of the circle. Let's watch a video of that. There's my radius, and we wrap it. Boom, we just created 1 radian. Now, watch something clever that happens. Aha! So what happened here was we started taking this radius and we laid it out on the circle. There's 1 radius, 2 radii, 3 radii, and a little bit more. And you know what number that became? Pi. So that was 180 degrees. We saw that in 180 degrees we had 3.14 radii. So now 180 degrees is pi. So now you know pi to mean 2 things. You know that pi is 3.14, and you just learned that pi, if we measured it in degrees, was 180 degrees. So pi has 2 meanings for you right now. And that means that in a circle there are 2 pi's. And if 2 pi's get you 360 degrees, and 2 pi also represented the circumference. Cool. So now what we're going to do is we're going to not use our lovely angle measures of degrees anymore. We are now going to refer to how far we rotated around in radians. So we started off right here. 180 degrees. Well, 180 degrees can be looked at 2 ways. It's half of a circumference, which in a unit circle is 2 pi. Half of 2 pi is pi. That's what our video just showed us. That if we went 180 degrees, we went halfway around a full circle. Well, 90 degrees. 90 degrees is a quarter of the way around 2 pi, a full circle. And a quarter of 2 pi is pi over 2. Or another way you could have looked at it is, since we figured out that pi was 180 degrees, I went half of 180 degrees. So now every time we see 90 degrees, we're going to say it's really half of a pi. So it may get a little tricky when we start getting into things that aren't perfect halves and perfect quarters. For example, 60 degrees. How does 60 degrees relate? Well, 60 degrees, compare it to 180. It's a third of 180. So I must have gone a third of pi. So that's what it is. 60 degrees is pi over 3. That's how we're going to write it in radian measure. We went a third of 180. So what's 120 in terms of pi? Well, here's where the clever people are going to step forward. 60, we just figured out to be pi over 3. And 120 are two 60-degree angles. So I must have two pi's over 3. So 60 is pi over 3, and 120 is 2 pi over 3. So if I went 120, that's what it looks like. And notice also that we're going to start dealing with fractions. Notice 2/3 is not quite a whole, so I didn't go a whole pi. I went 2/3 of pi. So that's how I can figure out if my angle is short of pi, or if I went beyond pi, it'd be an improper fraction or something that's more than 1. But we do have a formula for you. And some of you might have figured it out. And this I want to see written down in your notes in big letters, because you're going to do a lot of this. You are going to have to know how to take degrees and convert it to radian measure. And if you look over here, this is what this chart is going to practice. We're going to take a degree measure and we're going to turn it into radian measure. And this is the formula you're going to use. We're going to take our degrees and multiply it by pi over 180. And going back to algebra, we just proved that pi was 180. So really, you are multiplying by 1 here. So you're not changing the value. We're just changing how we refer to it. So 45. If I were to convert 45 degrees, that's what I do. I take my angle measure of 45 and multiply it by pi over 180. I do a little cross canceling. 45 goes into 45 once, 45 goes into 180 4 times, and pi over 4, a quarter of pi. 275, same thing. I'm going to do a little cross canceling. I believe 180 is 5 and 275. They have 5 in common, so 5 goes into 180 36 times. 5 goes into 275 55 times. And my answer is 55 pi over 36. Now, if I bring out my unit circle, just to give you, and notice my unit circle is still in degrees, because we're still trying to get used to this. This says it's 55 over 36 pi. Notice how this is an improper fraction. If I divided this out and got a decimal, it's about 1.52. So this means I went a whole pi, and then this says I went more than half pi. So this would be a half a pi and just a little more. And see where it gets me? That's right. Right at 275. So this is why we make the switch from angles to how far we rotate it around a circle. And that's going to become a little more evident as we move through the chapter. Right now, we just want you to be able to take degrees and convert them to radians. So let's kick down here to this easy one. 179. Well, if I convert it by multiplying it by pi over 180, there is no cancellation that can occur here. So I get 179 over 180 part of pi. And that makes sense a little more now, because I don't have a full pi here. I'm just a little short of being a full pi. So I'm going to rotate around. I'm just a little short of being a full pi. So here's our new friend, the unit circle. And notice it's written in radians. Some of you may be very upset. Pi over 6, this is really 30 degrees. Pi over 4, this is really 45 degrees. And pi over 3, this is really 60 degrees. And then pi over 2, this is 90 degrees. Well, we're going to use this unit circle a lot so that you're going to learn to count in fractions. So for example, let's pick this 4 pi over 3. This means I have 4/3 pi. So that means I have a full pi and a third pi more. So that means I have a full pi and a third of a pi. And if I did that, see, this is pi over 3. And if I clone that, see, that's 1, 2, 3, and I think you know see where this is going. 4. I have 4 of them. I have 1, 2, 3, 4 pi over 3s. And you're saying, well, how does this help me out? All right, get a load of the ugliness that's about to come. Right there. That is the unit circle with everything that you have learned. I have it in degrees, and then I have the radian equivalent, and then I have your 30, 60, 90 triangles listed with their answers. So the sine of 30 is 1/2, and the cosine of 30 is radical 3 over 2. Now, I know right now, Johnny Chisholm, you're going, what? But it's actually, there's a lot of patterns in here, and that's what math is all about, pattern recognition. So look, all you really have to understand is the first quadrant. It's pi 6, pi 4, pi 3. It goes backwards. All right, now look here. Radical 3 over, look at radical 3 over 2 and 1/2. Now, here it is again, and here it is again, and here it is again. And if you understand geometry and your reflections, if I take this point and I reflect it over the x-axis, all I do is negate the y. If I take this point and reflect it over the y-axis, I negate the x. And then if I take this point and reflect it over, whoops, I circled the wrong point here. Whoop, that's the one I should have circled. If I took this point and reflected it over the x-axis, I negate the y. So if I can create this chart very quickly and understand how this chart moves and see all the patterns that we're going to discover as we go through chapter 10, not going to be that bad. Okay, done.